little puzzle solving time. So if I want to find out what's the probability of A or B, and because I can see there's an intersection, so let's just think about this. It's going to be the probability of A or the probability of B, and I'm going to have to subtract off the intersection. Okay, so I know that this is 0.2 or 0.2, and then probability of A, they tell me is 0.6, and probability of B, oh, I just need to go figure that out. If B complement is 0.5, then B is 0.5, right? So I'm going to add on 0.5 and add all those together. I get a 0.9. All right, so let's look at this one. Looks like we've got 3 outcomes, and so each of them are labeled as one of the sets. And they tell me what the probability of A and the probability of B are. So I can see that there's no intersection, right? Because there's only 3 outcomes and each of them are set differently. So that means if I find a probability of A or B, I'm just going to add the 0.4 and the 0.3, so that gives me 0.7. What's the probability of C then? If these two add to 0.7, this has to be 1 minus 0.7, so that's 0.3. How about the probability of A or C? Well, I know the probability of A is 0.4, and the probability of C is 0.3, so 0.7. Probability of A complement, that's just going to be not A, and so that's going to be 1 minus 0.4, so that'll give me 0.6. Oh, I see De Morgan's going on here, so let's play with it. So this is the same thing as saying probability of A or B all complemented. And I know the probability of A or B is going to be, hold on a second. Probability of A, so it's going to be all of it subtract probability of A or B. And I figured out what the probability of A or B was in the very first step. So 1 minus 0.7, that gives me a 0.3. So this is very similar. Let's use the De Morgan's, right? So this is the probability of A and B complement, which is the same as saying 1 minus probability of A and B. Well, wait a second. There's nothing in common with A and B, so it just turns out to be 1.